Table 310.15b22 was a specific table found in the 2005 National Electrical Code, or NEC. It addressed conductor ampacity correction factors related to the number of current carrying conductors in a raceway or cable or earth when installed in close proximity, and the ambient temperature surrounding the conductors. To understand why this table number changed and how to find the equivalent information in the 2011 NEC, it's important to understand the structure and updates within the National Electrical Code. The NEC is revised every 3 years, so changes are common. These revisions may include new articles, modified requirements, or reorganization of existing content. In the specific case of Table 310.15b22, the information it contained was not removed from the NEC altogether, but rather reorganized and relocated to a different table number in the 2011 edition. The equivalent table in the 2011 NEC is Table 310.15b16. This table serves the same fundamental purpose as the older Table 310.15b22, which is to provide ampacity correction factors for conductors based on the number of current carrying conductors in a raceway, cable, or direct burial application, as well as adjustments based on the ambient temperature. To use Table 310.15b16, one must first determine the base ampacity of the conductor from Table 310.15b17 for conductors rated 0 through 2000 volts. This base ampacity is based on the conductor's insulation type and its temperature rating. The table provides ampacities for conductors insulated with materials such as THHN, THHW, THW, and others for both 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius temperature ratings. Once the base ampacity is determined, the next step is to identify the number of current carrying conductors in the raceway, cable, or direct burial application. It's crucial to accurately count the number of current carrying conductors, as this number directly affects the ampacity correction factor applied from Table 310.15b16. For example, if there are 4 to 6 current carrying conductors in a raceway, the ampacity of each conductor must be reduced to 80% of its base ampacity as determined by Table 310.15b17. If there are 7 to 9 current carrying conductors, the ampacity must be reduced to 70%, and so on. In addition to the number of current carrying conductors, the ambient temperature surrounding the conductors must also be considered. Table 310.15b16 provides temperature correction factors to adjust the ampacity of the conductors based on the ambient temperature. To use these temperature correction factors, the designer or installer must know the maximum ambient temperature that the conductors are expected to be exposed to during normal operation. If the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit, a temperature correction factor must be applied to reduce the ampacity of the conductors. For example, if a conductor with a base ampacity of 100 amps is installed in an ambient temperature of 40 degrees Celsius and its insulation is rated for 75 degrees Celsius, the temperature correction factor from Table 310.15b16 would be 0.88. Multiplying the base ampacity of 100 amps by the correction factor of 0.88 yields a correct ampacity of 88 amps. This means that the conductor can only carry a maximum of 88 amps in that specific installation environment. It's important to note that both the number of current carrying conductors and the ambient temperature correction factors must be applied cumulatively. That is, if both factors are present, both corrections must be made to determine the final allowable ampacity of the conductors. For example, if a conductor with a base ampacity of 100 amps is installed in a raceway with 4 to 6 current carrying conductors, and the ambient temperature is 40 degrees Celsius, the ampacity must be reduced to account for both factors. The ampacity correction factor for 4 to 6 current carrying conductors is 0.80, and the temperature correction factor for an ambient temperature of 40 degrees Celsius is 0.88. Multiplying the base ampacity of 100 amps by both correction factors yields a corrected ampacity of 70.4 amps. This means that the conductor can only carry a maximum of 70.4 amps in that specific installation environment. Understanding the correct application of Table 310.15b16 is crucial for ensuring the safety and reliability of electrical installations. Failure to properly account for the number of current-carrying conductors and the ambient temperature can lead to overloading of conductors, which can result in overheating, insulation damage, and even electrical fires. Therefore, it's essential for electrical designers, installers, and inspectors to be thoroughly familiar with the requirements of the National Electrical Code and to correctly apply the ampacity correction factors provided in Table 310.15b16. In summary, if you're working with the 2011 National Electrical Code, Table 310.15b16 is what you're looking for when determining ampacity correction factors based on the number of current-carrying conductors and ambient temperature. Always refer to the specific edition of the NEC that is in effect for your jurisdiction and consult with a qualified electrical professional if you have any questions or concerns about the correct application of the code requirements.